Alright, what's this? Looks like an Argentinian jackrabbit. Today I'm gonna show you how these little buggers reproduce. Follow me. Gosh darn, those Argentinian jackrabbits sure do run fast. Come on, let's follow them. Looks like we found the nest. These Argentinian jackrabbits are known for reproducing at an exponential rate, multiplying. Here you can see two of the babies and the fat mother. Let's go in for a closer look. I'm here with Jonathan Tong, the CEO of the World Wildlife Foundation here in Plano, Texas, Dallas, USA, the Milky Way. So I have some questions for Mr. Jonathan, and we're going to be asking him about the bunny population. So without further ado, here we go. Ba-bam. So, Mr. Jonathan, what do you think is up with the bunny population?
First, I'd like to say I'm glad to be with you, Joe. So normally the bunny population would be increasing because the crude birth rates are higher than the crude death rates. But you see, we Argentinians, we love our barbecue, so a lot of them are being hunted to eat. This puts them in a state of population decline, exponential decay. Let me show you.
Alright, here in Argentina we got an initial bunny population of 25,000. We got a decay rate of 15%. So how we're going to set this up is y equals initial amount, 25,000, times 1 minus the rate. So in here we'd be 1 minus 0.15, because 15% is equal to 0.15, and that gives us 0.85. So 0.85 times 0.85 to the power of x, and x represents all the years after 2012 is when we got the census for the 25,000 bunnies. So for instance, if I wanted to find 2015's amount, we'd go y equals 25,000 initial amount times 0.85 to the power of 3, because 2012 to 2015 is 3 years. So how we're going to do this in the calculator is 25,000 times 0.85 to the power of 3. And bam, we get y equals 15,353. So that would be the bunny population in 3 years from 2012 at this decay rate. Now let's talk about growth. Say we have a growth rate of 25%. In this case, the setup is basically the same. Y equals 25,000 times, instead of subtracting from 1, we add to 1. So 1 plus 0.25, that gives us 1.25. And also to the power of x, which is representative of the years after 2012. So John comes up to me and says, Joe, give me a 2020 amount, okay? That's simple. Y equals 25,000 times 1.25 to the 8, because 8 years from 2012 is 2020. So we go to the calculator, clear our previous amount. 25,000 times 1.25 to the power of 8. And bam, what does that give us? That gives us an amount of y equals 149,011. So that would be the population in 2020, 8 years from 2012. And that is how you set up growth and decay. Thanks for tuning in with me.